When a hospital cannot reliably or affordably access oxygen, the hospital must produce its own oxygen on site. The most common production method is pressure swing adsorption, or PSA. This is a pressure swing adsorption plant. It takes in ambient air and produces high-purity oxygen for medical use at medium pressures, roughly 3 to 4 bar or 45 to 60 psi. At the heart of the plant are 2 pressure tanks filled with a special material known as zeolite. As pressurized air is passed through the tanks, the zeolite traps the nitrogen from the airstream, resulting in high-purity oxygen leaving the tanks. To better understand this, let's take a look at a volume of air. Since air is approximately 78% nitrogen, 21% oxygen, and 1% other trace gases, removing the nitrogen from the air leaves us with gas that is 21 parts oxygen and 1 part trace gases. That is to say, it leaves us with oxygen that is approximately 96% pure. This is, of course, the maximum purity possible. The standard oxygen purity for a medical PSA plant is 93 plus or minus 3%. It's helpful to divide the plant into 3 stages: the air preparation stage, the PSA stage, and the oxygen delivery stage. We'll look at each stage in turn. We'll begin with the air preparation stage. Here, ambient air is pressurized, filtered, and dried. First, ambient air is brought into the compressor. Here, the air is pressurized to roughly 8 bar. Compressing the air produces lots of heat, which must be removed from the compressor, usually by air cooling. The pressurized air from the compressor cannot hold as much water as ambient air. Because of this, the humidity in the compressed air will quickly form condensate in the air lines. Condensate can damage the zeolite, so it must be removed. This is the job of the air dryer. The most common type is the refrigerated dryer. Here, water is removed by cooling the air to near freezing temperatures, forcing even more water to condensate out of the air. This water is removed via a condensate line. A series of coalescing filters are used to both filter out small particles, as well as remove any leftover droplets of water or oil that may have escaped the compressor or dryer. The PSA does not use air at a constant rate. Instead, the air demand fluctuates with the PSA cycle. The air tank helps stabilize the pressure by keeping a reserve of compressed air for periods of high demand. While a functioning dryer removes the vast majority of moisture from the air, it is still possible to get condensate in the compressor, filters, and air tank. It is common to see condensate lines going to each of these parts. The lines are periodically opened to empty any condensate that has collected. Let's take a close look at the PSA. Here, the dry, filtered, pressurized air from the previous stage flows through the zeolite. At high pressures, nitrogen in the air will stick to the surface of the zeolite. This is known as adsorption. While nitrogen is adsorbed by the zeolite, oxygen and other trace gases pass through. After a short time, the zeolite becomes saturated with nitrogen. Before it can be used again, the zeolite must be cleared of nitrogen. To do this, the tank is vented to the atmosphere. As the pressure in the tank drops, the trapped nitrogen will desorb or unstick from the zeolite. Once all the nitrogen is vented, the process can be repeated. To produce a more consistent output of oxygen, most PSA plants use 2 tanks, so that one tank is filtering while the other tank is venting. Now that we're producing high-purity oxygen, we want to deliver it to where it is needed. This is the oxygen delivery system. First, oxygen is sent to the oxygen storage tank. Like the air storage tank, the oxygen storage tank is used to help stabilize oxygen pressure. Oxygen from the storage tank can be distributed directly to patients' beds through an oxygen piping system in the hospital. Alternatively, oxygen can be stored in cylinders by means of a high-pressure booster pump. These cylinders can be used directly by the hospital or can be distributed to smaller local clinics in the hospital's catchment area. A hospital may use a combination of either of these distribution methods, depending on its needs.